AC motor, types, principle, construction, and working. What is AC motor? AC motors use magnetic fields and an external power source to create rotary motion. An AC motor converts electrical energy into mechanical energy. It has a stator and rotor. The stator is the stationary spinning part of the motor, which typically looks like one or more metal bars through which many wires are wound. These wires carry the electric current that windings of wire on the rotor convert back into mechanical force to spin it. The strongest magnetic field created is concentrated in this part of the setup because that's where there are more turns on coils of wire. An AC motor is an electric motor that runs on an alternating current, AC. Working of an AC motor? An AC motor has coils that are wired in the opposite direction of the usual electric current. Instead of the earth having a negative charge, it has an opposite positive charge and vice versa. When these coils are switched on by an electromagnet, they induce electric currents in these oppositely charged wires by working against the effects of conventional electrons. Consequently, it will spin one way until the difference between west and east forces becomes too great to overcome at a point. Types of AC motors? The two major types of AC motors they are as follows. 1. Induction motors and synchronous motors. Induction motors are the most common type, and they work by using a rotating magnetic field to induce a current in the rotor. Synchronous motors work by using a permanent magnet on the rotor to synchronize with the AC current. AC motors are available in a variety of sizes and power ratings, and they can be used for a wide range of applications, from small appliances to large industrial machines. High-efficiency AC motors are very efficient, and can achieve efficiencies as high as 95%. This is much higher than the efficiency of DC motors, which typically range from 50% to 70%. Synchronous motors are found in electrical grids because they can be controlled by varying the frequency at which they are driven. Synchronous AC motors do not tend to self-rotate, so will operate more quietly but are not suitable for use at grid frequencies. The major difference between the two kinds of motors is the way they generate the rotating magnetic field needed for driving. A permanent magnet motor also does not need an outside source of electric power but requires more starting torque than an induction motor before it will run at full speed. Synchronous motors use rotating magnetic fields synchronized with the AC supply frequency, 50 or 60 Hz, to create torque. It's different from an asynchronous induction motor or brushless DC motors, which need to be running before any torque output will manifest. 2. Permanent magnet motors. Asynchronous AC motor is a type of electric motor which can have an on torque, meaning it will turn at some speed when the input voltage is applied. Permanent magnet motors use magnets to create the rotating magnetic field. These motors are smaller and lighter than induction or synchronous motors, but they are more expensive. Permanent magnet motors also have a higher efficiency than induction motors. A permanent magnet AC motor, MAG, is a type of electric motor driven purely by AC power. It consists of an armature with coils on the rotor, and the field poles on the stationary stator are magnets that provide magnetic interaction to produce torque. Typical designs use shaped, although other shapes are possible, steel laminations for the majority of flux path, with rare earth magnets providing current confinement in gaps around pole pieces. A permanent magnet motor is a type of electric motor that uses permanent magnets to create the rotating magnetic field that powers the motor. Unlike an induction motor, which uses an alternating current to create the rotating field, a permanent magnet motor uses permanent magnets to create a static field. This has the advantage of not requiring an AC supply, which makes them useful for applications where a reliable power supply is not available. Permanent magnets are made from materials that have a permanent magnetic field, such as iron, nickel, and cobalt. They can be in the form of a magnet block, bar, or plate. Many permanent magnet motors provide very consistent torque, hence the use in applications such as electric vehicles. Principles and construction of AC motors. AC motors have two main principles of operation: different speeds and different torque. They work on the principle of the rotation of a circuit from high voltage, low amperage to a low voltage, high amperage. AC motors first create a rotating magnetic field with an AC that is switched on and off at a constant frequency. So if the resulting magnetic field rotates clockwise, then applying a DC in one direction will cause clockwise rotation as well as attraction forces to other nearby magnets or ferrous materials such as iron cores or steel laminations. In contrast, reversing this polarity by switching on the same magnitude DC in the opposite direction will reverse both rotation and attraction force directions from those before reversal. The brushing motors of the past would wear out quickly because their brushes would constantly contact parts of the armature with high voltage. Therefore, synchronous motors were developed. Synchronous motors are induction motors that operate on a single-phase power source, hence their name: single pole, single phase, 1p1. Synchronously operating induction motors have two poles on shafts surrounded by stationary magnets. The electrical current alternates between these poles. AC motor is that the rotation of the motor is caused by alternating electric current traveling through the cores. The direction of this current flows changes at a specific frequency. Thanks for watching.